All right. So this SuncatByte is going to be a SuncatByte talking about Program 2 test cases, which is the MiniCooper program. So as always with test cases, I'm going to assume that you have read the test case spec doc and the actual spec. So here's the actual spec. Bunch of information in here. Key things to look at when you're looking at the test case is we want to make sure that we answer these 3 questions in the test case. And when they're given some information in here that's useful, right? With the dimensions of the bar, the 2-door hardtop and 4-door hardtop, and the different cargo spaces for those, and then that both Mini Coopers are 1,800 pounds. Keep that in mind as well as we go through this. So the first test case that we're looking at, and that's going to be the only one that I kind of go over today. The other ones, you follow the same steps or same algorithm, right? But the one that we'll be looking at today will be the 2-door Mini Cooper with aluminum and 100 bars. So, looking at that, I'll put those assumptions here at the top. 2-door Mini Cooper, aluminum, 100 bars. So the density of aluminum that I use by doing an internet search is 0.098 pounds per inch cubed. And then the cargo space of a 2-door is going to be 24 cubic feet. And that comes from, cubic feet. And that comes from our spec. So, Mini Cooper here. "24 cubic feet of cargo space right there. If you're doing the 4-door, it has 32.8 cubic feet. So keep that in mind when you're doing the other calculations here. All right. So now we have our bar volume. In inches is going to be 7 inches, right? Times 3.625. Times 1.75. Which is going to give us 44.40625 inches cubed, or cubic inches. So that's the bar volume of 1 bar, 44.40625 cubic inches. Now we have our questions. Or something else to keep in mind, right? Density is equal to mass divided by volume, which written another way, mass is equal to density times volume, or volume equals density divided by mass. Just remember those equations. So, first question in the spec that we want to answer, and that we want to answer in the test cases, is this: consider the bar's total weight. Can the car carry the bars based on their weight? So in order to figure this out, we need to know what the weight of the bars are. So first, let's figure out a single bar. So a single bar weight is going to be equal to the density, which is 0.098, times the volume of a bar, which we just figured out above, which is 44.40625. That's going to give us 4.3518125 pounds. So then what's the total bar weight? We just multiply that by the number of bars, right? Total bar weight is going to be equal to that number. I'm going to cut and paste. Times 100 which is going to be 435.18125 pounds. So then the question was, can the car carry the bars based on their weight? It can. So what we're basically saying is 435.18125 less than 1,800 pounds. Remember, the car can carry 1,800 pounds. It can, so the answer to this question is yes. Oops. I don't know why it's... Okay. So that's the first question. Well, our next question was from the spec. Consider the volume. Will they fit in the chosen Mini Cooper space? So let's put that question here. Go up. So in order to do that, we need to start looking at volume, right? So what's the cargo volume in inches? We have the cargo volume given to us as 24 feet cubed, right? We want to convert that to inches. We multiply by 12 3 times to give us cubic inches. So that's going to give us 41,472 inches cubed. So that's the volume in inches that the two-door Mini Cooper can carry. Now we want the volume of the bars. So that's going to be our 100 bars times the volume of, given the Fort Knox measurements, which is up here, right? 44.40625 inches cubed. So now the volume of our bars will be 4,440.625 4,440.625 inches cubed. And then to answer the question, will they fit? What we're really asking is 4,440.625 less than 41,472. It is, so the answer to this question is yes. All right, last question we have to answer, again from our spec. Calculate how many bars of the user's chosen metal it would take, not would it take, to make up the 1,800 pounds, and will these bars fit in the Mini Cooper's cargo space? Let's find out. Okay, come on, there we go. So, in this case, the number of bars in 1,800 pounds would be equal to 1,800 divided by the weight of a bar, which for for aluminum is 4.3518125, which we calculated up here, right? 3518125. So that'll give us 413.62076146. Since we're going to have bars, take the ceiling of this or round up. So when you're programming hint, you'll use ceil. That's going to be 414 bars. Now, we want to take those 414 bars and multiply them by 44.40625 0.18625, which is the for volume, right? And that's going to give us 18,384.1875 inches cubed. So then we just basically ask that same question that we did above, is 18,384.1875 384.1875 less than 41,472. It is, so the answer to our third question is also yes. It will fit in the cargo space. It's going to take 414 bars. So really the answer is both of these. It's this. Oops. And this, right? And then here the answer was yes. And here the answer was yes. Oh, whatever, that works. Yes. Questions from those of you that are online now? Okay, we have a question from Nathan. Go ahead.
Can you hear me?
Yep.
Okay. My mic cut out when you were mentioning the three equations up top, the D equals M divided by V.
Yeah.
What was 4 again?
That's just a density equation, right, for mass and volume. So we end up using that when we're calculating mostly here, right, in the total weight. So when you calculate the weight, M equals D times V, we don't have the mass, but we have the density of aluminum here, which is 0.098. And then we have the volume of a bar, which is 44.40625. So that's how we get that mass or the weight for a single bar. So that's just where that's used.
Okay, so it's just density equals mass and volume, or
And that, yeah.
Okay.
Yeah, those are just different permutations of the same equation, right? So in this case, we use mass equals density times volume.
Okay, thank you.
You got it. Any other questions? No? All right, I'm going to stop the recording now then.